Alright, Assalamualaikum and salam sejahtera. Today I would like to just give you some short tutorial regarding boiling and condensations. So for this, if you, I assume that you already go through the slides and also go through the short video regarding boiling and condensation. So basically this is just recap of it. So when we have this is typical boiling curve for water at 180 temperature. Okay. So it actually has four different sections. The first one is natural convection boiling from 0 to A, and then we have a nucleate boiling from A up to C, then we have a transition boiling from C up to D, and we have a film boiling from D up to E. Alright, so actually this is all depends on the T axis. Is different by minus Ts surface minus T saturated. T surface means the surface of the kettle, surface of the equipment that you have, and minus the saturated means the temperature of the water. So if it is between 0, this is 1 until 5, so it is natural convection boiling. If you minus it between 5 up to 30, it is nucleate, and 30 and above up to 120, it is transition boiling, and above 120 means it is film boiling. Okay, nucleate, you can imagine as it have a nucleus that bubble up, and this is transition between nucleate and film boiling. This is film, and they have a film, a very thin layer between the surface and also the water. Okay, basically this is books of heat and mass transfer. Fundamental, you could get it if you are in sea, you could get from the library. If you are at home, this is actually available somehow in the internet, but you have to find it. Okay, so let's go for this is nucleate boiling. This is the how we want to calculate Q for nucleate boiling. Small q dot. So this is the formula. It has of all the viscous of the liquid, enthalpy, evaporation, cavitation, acceleration, and so on. Everything is here, and so we have in the formulas. So where to get it? Let's see an example of it. So actually they have some table here. You have table 10.1, surface tensions of liquid vapor interface waters, and you have table 10.2 surface tension for some liquids, and you have table 10.3 CSF, coefficient of CFF, and also N for various fluid liquid combinations. So this is CSF and N's. Okay, let's have a look on the example. Okay, example number 1. For example, here we have heating of waters, 100 degrees Celsius, and we measure that this is the container of it. We measure it is 110. So here we like to determine the rate of heat transfer to the waters, also the rate of evaporation of the waters. So basically given here that the bottom of the pan is 30 degrees Celsius, and the bottom of the pan means the diameter is 30 degree from here up to there, 30 degree diameter, and then measure 100 each. And here what we need to find is actually when we see this one, what we must do, the first thing for try to find out this whatever property is it issue here, the first thing that we should find is T axis. We would like to know whether this is nucleate, film boiling, transition boiling, or what. So we minus 108 minus 0, 100, we got 8, so means less than 30. Therefore, this is nucleate boiling, because both than 5 is nucleate. So this is formula for nucleate. Okay, when we have a formula for nucleate, then you have to find what is mu, HFS, and so on. And then, if you want to find this one, we will refer table 10.1 and also table E9. Okay, to find all the data that we need. Type these formulas, we could get a Q, which is equal to 7.21. We get Q small q nucleate, and then we'll find the area equal to pi d to the power of 2 over 4, get 0.07 meter squared. The rate of heat transfer during nucleate boiling is which is equal to because this is small q, so to get a bigger q, we got q equal to E times q dot small q, then we got 5000 watts. That's the answer. And rate of evaporation water, which is equal to m dot equal to q boiling over HFG. HFG is over there. HFG, okay, fluid liquid. Then we got 2.26 times 10 to the power of minus 3. Okay. Okay, let's have a look on the next example. This is, for example, we have a heating element, and then we have a vapor films, and this is at 1 atm actually. So here has been given that horizontal polished copper heating element diameter D equal to 5 mm and emissivity epsilon equal to 0.05 immersed in the waters, shown as 10.17. If the surface of the temperature of heating wire is 350 degrees Celsius, determine the rate of heat transfer from the wire to the water per unit length of the wire. Okay, so here, before we do anything, same as above, we need to know the T-axis. So T-axis is equal to Ts minus T saturated, which is equal to 350 minus 100, which is equal to 250. Okay. This is bigger than 630 for water, means this is film boiling. So just plug in this formula first, so we get this Q films. Yeah. Then we need to find whatever that this small notation. We need to find everything. Yeah, this we could find by using table A9 and also table A16. Okay. So by having these two tables, we could get all the data that we want, okay, and plug in everything back towards this equation, and we got the answer is equal to 5.63 times 10 to the power of 4. Okay, and then the radiation heat flux is determined by using equations E 10 to 6 is equal. This is normal equation actually. Radiation equal to epsilon sigma Ts to the power of 4 minus T saturated. We got Q radiation is equal to 372. So to find the Q total, because here we got Q film, so we got Q radiations, because it's in heating elements. Their films, Q film and so Q radiation. Actually, Q radiation could be neglected, but here we still calculate it by using these formulas. Q total is equal to Q film. You see, this is power of 4 already. This is hundreds only. So Q films plus 3 to the power 3 over 4 times Q radiations, which is equal to in total 5.69 10 to the power of 4, which is nearly equal to the above one. Okay, that's why they said here that curation could be neglected. And then to find the Q heat transfer, because yes, Q small is heat flux actually. So to find the Q total, just time the heat flux by A, and we got 936 watts. This is the Q total we need it. Alright. Okay, your task. This is your task that try change the formulas, try change the temperatures. For example, here is still 100 because it's water, so I need you to change this to 370. 370. Try to calculate and give a feedback. Alright, thank you very much.